Okay, this continues section 5.4, and I want you to do this example number 23 all by yourself. So copy these problems down or pause the video right now, work them, and then turn it back on, and you can see how well you've done. Okay, hopefully you've had time to do those examples and you can see how you're doing. So we see here that we have a slope of 5 and we have a point because the x is not 0, that's not our y-intercept. So we're going to put into point slope form. Y minus our y-coordinate of the ordered pair is equal to our slope 5 times x minus the x-coordinate of the ordered pair. And now we'll simplify. Distributive property comes first, so y minus 2 is equal to 5 times x, and then minus 5 times 5, which is 25. Finish by simplifying by adding the 2 to both sides, and now we have y is equal to 5x minus 23. And as always, we can check to see if this is really our equation because we can see if it satisfies, or this point satisfies it. 5 times 5 is 25. 25 minus 23 is 2. Yep, it satisfies it, so that's our equation. Don't forget that another way we could write this would be to use function notation. F of x is equal to 5x minus 23. Don't want you to forget what we learned before. All right, our next one, we have two ordered pairs. The first thing when we have ordered pairs, we want to check, are the x's the same? 2, negative 2. Nope, not the same. Negative 5, positive 7. Nope, y's aren't the same either, so it's neither horizontal nor vertical. So the first thing we need to do is to find the slope. y2 minus y1, 7 minus a negative 5. Do not forget to write that as a minus, and then negative 2 minus 2. And so now we have 7 plus 5, which is 12, over negative 2 minus 2, which is a negative 4, because that's negative 2 plus a negative 2. And now we simplify. Positive divided by a negative is a negative. 12 divided by 4, which is 3. Now we can choose an ordered pair. Either one will do. I'm going to go ahead and choose that one, and I'm going to put it into my point slope form because we notice that neither of my x's are 0, so the y-intercept is not known. Y minus our y-coordinate here, a negative 5, and that is equal to my slope, negative 3, times x minus, and then my x1, which is 2. Simplify by distributive property first, so y minus 5 is plus 5, and that's equal to negative 3 times x, which is negative 3x, negative times a negative, which is positive 3 times 2, which is 6. Last, move the 5 over to the other side by adding its opposite, and we finally get y is equal to negative 3x plus 1. And then, of course, we can check and see if both of those ordered pairs satisfy it, and we'll know if it's the correct equation. Our last one is a visual example, so we need to find the slope by using rise over run. And so we're going to, first of all, check to see our rise 1, 2 down. So a negative 2 over, and then run 1 to the right, so positive 1. So my slope is a negative 2. Notice that I have no idea what that y-intercept is. I can't use anything but point slope form. So I'm going to use one of my ordered pairs. Doesn't matter which one. Remember, to get it, I have to simply find where it is on the x-axis. X equals 3. And the other one, y equals negative 2. And so there's my ordered pair. That's a messy 3. Sorry about that. And so now my y, negative 2, and that's equal to a negative 2 times x, and then minus my x-coordinate, positive 3, and now simplify. Distribute, distribute, so y plus 2 is equal to negative 2x, and then negative times a negative is a positive 6, and then move the constant over to the right, so y is equal to negative 2x plus 4. And now we know what the equation is. We can see if it satisfies the points that we have or not. And x equals 3, so that's a negative 6 plus 4 is a negative 2. Yep, satisfies that one. We can check the other one as well.